Augmented reality applications are slowly making their way into the world of the consumer. Pokemon Go created the magical experience of seeing Pokemon superimposed upon the real world. IKEA's mobile app lets you see how a couch would fit into your living room, which has a significant improvement on the furniture buying process. Augmented reality applications can have even more dramatic impact on industrial enterprises. Have you ever set up a factory? You might need to build a conveyor belt. You might need to put together the parts of a giant machine that extrudes steel. You might need to fix a silicon wafer fabrication machine. It takes an expert to set up these heavy, complicated machines. ScopeAR is a company that builds augmented reality tools. One of these ScopeAR products allows users to telepresence with each other to collaborate on the construction and maintenance of heavy machinery. Imagine I'm setting up a factory, and I have a complicated piece of machinery, let's say a conveyor belt, in front of me. I've never constructed a conveyor belt before. I put on a Hololens, and I set up a VoIP call with an expert who has experience with that piece of machinery, and they point out what I need to do by superimposing 3D arrows and text and other instructions on my field of vision. They can share my experience and help guide me through the process. This is such a flexible tool. You can imagine applications for augmented reality assistance being useful in medicine and construction and education and lots of other fields. Scott Montgomerie is the CEO of ScopeAR, and in today's episode we talk about the state of AR, how the AR tools from Apple and Google compare, and how the similarity between the tools used for mapping the world in AR relate to the tools used to map the world by autonomous cars. It's actually very similar technology. Scott was a great guest, and I hope to have him back in the future. We've done some other great shows about augmented reality and virtual reality applications, as well as the nature of reality. You can find these old episodes by downloading the free Software Engineering Daily app for iOS or for Android. In these podcast apps, you have access to all of the episodes of Software Engineering Daily, whereas in your normal podcast player, you only have access to the most recent 100. And with these apps, we're going to build a new way to consume content about software engineering. Right now, it's only the podcasts, but over time, we're going to expand it to other forms of content. And they're open sourced at github.com/softwareengineeringdaily. If you're looking for an open source project to get involved with, we would love to get your help. Shout out to today's open source featured contributor, Edgar Pino. He is working on a real-time chat application for Software Engineering Daily so that we can have chat rooms for people to discuss the episodes easily. It's a really innovative piece of work, and I'm happy to have Edgar contributing to the open source community. With that, let's get on with this episode. You are programming a new service for your users, or you are hacking on a side project. Whatever you're building, you need to send email. And for sending email, developers use SendGrid. SendGrid is the API for email, trusted by developers. Send transactional emails through the SendGrid API. Build marketing campaigns with a beautiful interface for crafting the perfect email. SendGrid is trusted by Uber, Airbnb, and Spotify, but anyone can start for free and send 40,000 emails in their first month. After the first month, you can send 100 emails per day for free. Just go to sendgrid.com/sedaily to get started. Your email is important. Make sure it gets delivered properly with SendGrid, a leading email platform. Get started with 40,000 emails your first month at sendgrid.com/sedaily. That's sendgrid.com/sedaily. Scott Montgomerie is the CEO of ScopeAR. Scott, welcome to Software Engineering Daily.
Thanks. Great to be here.
I want to talk about everything in AR that we can get to in the next 40 to 60 minutes. But let's start with the state of AR and what you're working on. What are the low-hanging fruit applications where AR is actually useful today?
It's interesting. The AR landscape has gone kind of a dramatic shift in the past 6 months since Apple came out with ARKit, and that's kind of brought the word into the common lexicon now. Everybody knows what augmented reality is. So, I still think that we're a ways away from finding the killer use case in AR. We've been focused on AR for, over 5 years, and have been kind of gradually grinding out the typical use cases that are really providing value. So I think almost everybody sees the initial value in augmented reality is in the enterprise. Part of the reason for that is that augmented reality, it's still nascent. The hardware, especially wearables, is clunky. There's a lot of limitations to it. But if you solve the right problems and, saving a lot of money with enterprises, they're more than willing to overlook those limitations to get their workers to use this nascent technology. And they're definitely leading the way. So in particular, I think layering augmented reality on top of remote assistance applications is really interesting. Part of the great aspect of augmented reality is that it allows you to communicate better, more visually in a 3D space. And it's just a lot more natural to interact in 3 dimensions. And so in a remote assistance use case, you've got technicians and experts collaborating over video, and if you're just using FaceTime, you're still telling a guy what to do. It's like, hey, look at that thing on the left or the right or whatever. No, not that left, the other left. No, not that left. And so if you've got an augmented reality experience, you're able to, add 3-dimensional annotations on top of the reality, and it goes a long way towards improving communications and collaboration, right? And then the second use case I think that everybody's exploring is work instructions. So being able to show you more in-depth illustrations and communicating how to perform things. So in a very basic way, with Google Glass, you've got text-based instructions that are just overlaid on top of your glasses. Just more things that we do more commonly are actual 3D models overlaid on top of equipment showing you how to do things. So augmented reality really allows you to communicate intention a lot better and leaves a lot less room for error and miscommunication.
Yeah, you've described the ScopeAR product at this point. So if let's say I am running a factory, a company that does factories, and I'm making my factory makes speakers, for example, and within this factory that makes speakers, there's all these complex pieces of machinery. There's steel extruders or big complicated saws or things like that. And if I'm setting up a new factory, let's say, I got one factory and it's going great, and I decide I'm going to expand to another factory on the other side of the country, and the person who is setting up this new factory, they've got to set up all this complicated machinery, and they've got to understand how to use it. And the people at the original factory, they know how to use that technology. But unfortunately, they're across the country, and they're not present with me setting up the machines in the factory. This is where ScopeAR can be useful, because I can get on a remote telepresence call with somebody at the factory that's already been set up, and they can walk me through the setup of this complex machinery while I'm wearing, for example, a Hololens, and they can see what I'm seeing and can place little arrows and instructions and helpful visual guides that will be overlaid across my HoloLens and will guide me through the process. Am I giving an appropriate use case of ScopeAR?
Absolutely, that's exactly what we do. But there's a whole bunch of other enterprise use cases that are kind of similar as well that we don't really focus on. Things like warehouse part picking. So if you can, let's say you're in an Amazon warehouse and you are walking up to an aisle with 100 feet stacked of boxes. How do you know which part to go pull and do that as efficiently as possible? Well, if you use augmented reality to be able to highlight the box and guide you how to get there, that's a heck of a lot better efficiency than paper and trying to do it the old-fashioned way, correlating an ID number, or even they used to use QR codes and go and scan those, but that's also a little bit inefficient. If you can actually see that in 3 dimensions where to put it, a heck of a lot more efficient. And then in terms of packaging, you can get an algorithm to optimize how to package boxes. And then it shows you how to do it, and then you go ahead and do it. So you can save a lot on space and just, again, more efficiency. So, it's all about that user interface layer and allowing computers to help you do things in the real world and in a real task. And that's really where we're seeing almost all the value in AR.
So let's talk through some more practicalities, and then we'll get into the engineering. Are there serious workplace safety issues that happen because people don't have clear sets of instructions for how to use heavy machinery?
Yeah, definitely. I think we haven't seen a lot of benefit, improving safety with heavy machinery so much. We've certainly seen a dramatic, and I think the reason for that is that those industries, because they're so safety conscious, they're a little bit averse to new technologies. They have the procedures that are established. They've done them a certain way because they've learned a lot of mistakes along the way, and so they don't really want to change right now. But in the same vein, we have seen a dramatic decrease in error rate in a whole lot of different use cases. So in terms of manufacturing and assembly instructions, and then in terms of maintenance use cases. So because you have these visual instructions that are guiding workers how to do things, the author of those instructions can communicate his intent of how to perform a procedure much more clearly than with just text-based instructions or verbally. So if we think of a really basic example like IKEA furniture, for example, everybody screws up IKEA furniture. When I talk about the company, I would say 3/4 of the time somebody's like, "Oh man, I wish I had this for IKEA," right? Because it's just a common thing.
That's why they bought TaskRabbit, right?
Yeah, exactly. That's right. Exactly. But if you were able to see that furniture being built in front of you, step by step in 3 dimensions, you would never put something on the wrong way or use the wrong screw or anything like that. The whole reason we screw up IKEA furniture is because the instructions are poorly communicated and we misinterpret them. So if you take that to a much more complicated procedure and a much more high stakes procedure, like manufacturing or heavy equipment maintenance, it just makes a lot of sense. And you can see why the error rate is significantly decreased. And we're seeing in some cases we're decreasing error rates down to exactly 0. So it's pretty impressive.
And what about medicine? So my dad is a doctor. I talk to him a lot about telemedicine. Are there applications today for AR in the telemedical industry?
Yeah, absolutely. We're in discussions with a couple of companies doing interesting use cases. We haven't got super far yet, but they're certainly excited. For us personally, we've stayed away from medical just because there's a lot of low-hanging fruit in heavy industry, and we've got to target, a certain niche. But I think there's a lot of opportunity in telemedicine. One of the success stories in medicine that I've heard of is Augmented, and they're just using Google Glass as a recording mechanism. So they're essentially just using it as a head-mounted video camera to record a session between a patient and a doctor. And that dramatically decreases the amount of data input that doctors have to go through because, doctors spend a significant amount of their time writing up charts and essentially doing basic data entry. And they can't offload that because they're the ones that understand the problem and have the communication with the patient. But if you can record that using Google Glass, then that's interesting. It's not exactly a great use of augmented reality, but, for head-worn displays, it's interesting. One of the use cases that we actually have seen is training in terms of medical equipment, which is kind of an offshoot of heavy industry, just applied to the medical field. So if you can, hospital equipment in particular is very complicated, and training is expensive and costly if you do it wrong. But again, because of the improved communication, if you can show in augmented reality how a particular device is supposed to be used, then there's an immediate benefit.
If I'm an Amazon warehouse worker and my day is spent walking around the warehouse and picking items off the shelves and putting them into boxes, the goal is obviously to get a robot doing this because this is not work that we should have humans doing. This is highly automatable, and we're trying to figure out how to train machines to do this. You could imagine somebody walking around with a headset that has a camera on it and recording their view of the world and the things that they pick, and you can imagine also giving them AR hints about where they should be going and what they should be picking from. And in an ideal world, maybe you would be able to use that the data, like the hints that we're giving to the humans, to train eventually machines. And maybe you want to give humans the same kind of hints that you eventually will give machines, and then the machines can just learn to do the picking that way. Is that a fruitful avenue for us to pursue, or am I thinking down the wrong avenues of the future?
No, I think that's perfect. You're exactly right in that, right now robots need to be trained in how to perform tasks, and by a lot of industrial robots are trained by watching humans actually perform that task with computer vision. So part picking is no different. Ideally, you're absolutely right. You've got this head-worn headset tracking where you are, probably mapping out the 3D mesh of the facility, understanding in 3D where the parts are going. That would entirely be possible. There might be more efficient ways to do it, but I think your line of thinking is right. And like I said, that's certainly one of the most interesting use cases of augmented reality.
So you said we have seen industrial applications where machines have been successfully trained by watching a human?
Oh yeah, I mean, a lot of the robots used for assembly need to be trained somehow, and so if you've got a human hand that is able to assemble something, that machine can also see how to put it together. I'm not an expert in robotics, but I'm pretty sure I've seen this in some of the automotive factories I've visited.
At Software Engineering Daily, we need to keep our metrics reliable. If a botnet started listening to all of our episodes and we had nothing to stop it, our statistics would be corrupted. We would have no way to know whether a listen came from a bot or a real user. And that's why we use Encapsula, to stop attackers and improve performance. When a listener makes a request to play an episode of Software Engineering Daily, Encapsula checks that request before it reaches our servers, and it filters the bot traffic, preventing it from ever reaching us. Botnets and DDoS attacks are not just a threat to podcasts. They can impact your application too. Encapsula can protect API servers and microservices from responding to unwanted requests. To try Encapsula for yourself, go to encapsula.com/2017podcasts and get a free enterprise trial of Encapsula. Encapsula's API gives you control over the security and performance of your application, and that's true whether you have a complex microservices architecture or a WordPress site, like Software Engineering Daily. Encapsula has a global network of over 30 data centers that optimize routing and cache your content. The same network of data centers are filtering your content for attackers, and they're operating as a CDN, and they're speeding up your application. They're doing all of this for you, and you can try it today for free by going to encapsula.com/2017podcasts, and you can get that free enterprise trial of Encapsula. That's encapsula.com/2017podcasts to check it out. Thanks again, Encapsula. That's pretty cool. Okay, well, I'll need to interview somebody about automotive stuff. Let's get into engineering. ScopeAR was started, you just said 5 years ago, but I thought it was 7 years ago. I think it was something like that, or
yeah, it's a little bit of a gray area. So officially, we started in 2011. So yeah, it would be 6 years ago.
Okay, sure.
So, and I guess unofficially it started even further than that. So the way we had started was I had developed some computer vision technology for another purpose. I was actually trying to build a game for the Apple TV. And this didn't really pan out, mostly because the Apple TV never came out with an app store. And so, once the WWC came and went and there was no app store, I was kind of like, well, crap, what the heck do I do with this computer vision technology I spent so long perfecting? And I realized that it could actually be applied to augmented reality. And so we started looking at, interesting use cases. We started looking at marketing and advertising use cases. But of course, this was 2011. And, even still, we're not really seeing advertising and marketing use cases take off. But, certainly before AR was even in the lexicon, people were not willing to pay for this crazy new advertising platform in AR. But we had a customer that came to us and said, hey, can we use this for training? And so we did a really quick proof of concept with them. It went really well. And then they said, cool, we want to show this at a trade show. And so this was a giant mining trade show in Las Vegas. And it was a big company, so we had pretty much the best spot on the floor in this giant trade show. And it was a bit of a novelty at the time. We were supposed to show it a few times a day over the 3-day show, and we ended up showing it over 100 times. And every time we showed it, people were coming up to us being like, "Oh my God, this is the coolest thing I've ever seen," which was really impressive because, the machines we were sitting beside were these like 6-story giant mining trucks that you find in, the oil sands in northern Canada. And, with us, with our, little geeky augmented reality thing, people were saying this was the coolest thing at the show. So that was pretty cool. But the stories we heard from people about how they could see this in the field were really why we started doing what we do. One gentleman in particular came up and said, "This exact piece of equipment you guys are showing, I've been maintaining this my entire career for 35 years, and just now I learned how to do it properly. I've trained hundreds of other guys to do it the wrong way. I've probably shortened the lifespan of this thing the way I do it. So I've probably cost my company tens of millions of dollars by doing it the wrong way. So I need this technology. How do I get it now? Like, sell to me right now." And so, just hearing that kind of story, we were like, wow, apparently we found something here. We should probably pursue this. And that's really how we got kickstarted.
Sure is interesting how many successful products come out of ill-fated games.
It's true. It's true.
So you stumbled onto this augmented reality set of use cases. Did you have any background in computer vision? I mean, what did you need to know about computer vision 6 years ago to start an augmented reality platform?
Yeah, so no formal training in computer vision. I actually did my degree in bioinformatics, which was kind of a combination of computer science and genetics. So essentially, I was writing algorithms and machine learning algorithms to analyze the human genome and do protein folding. But, I've always been a guy that just, if I have a problem, I figure out a way to solve it. And so, basically just started playing around with OpenCV and started building things around OpenCV and doing augmented reality that way. So, yeah, no formal training, just kind of, grinding and figuring out how to solve the problem.
Give me a little bit of the story of what happened after that conference where you were talking to somebody in a mining company. I mean, I'm sure you came home from that conference with adrenaline pumping through your veins, just think, wow, this is actually a huge set of opportunities. We could build augmented reality stuff to train people to do all kinds of stuff. Where did you go once you had that adrenaline pumping through your veins?
Yeah, I mean, so clearly it was very early, and we'd stumbled upon something, but we had absolutely no idea how to turn it into a viable business. So we started essentially consulting. So we got contracts from guys like Boeing and Toyota and NASA, building out initial proof of concepts with them, and eventually we realized that all of the proof of concepts we were building came down to a common set of use cases and something that we could build into a platform. And this was a novel platform, and it was going to solve a whole lot of the problems that were going to happen at some point when this became viable. So, scalability, maintainability, ease and speed of authoring these types of instructions. And so, after those, first a few initial use cases and a whole bunch of others, we started building a platform to solve those. And that was really the genesis of our products.
And I want to just point out, again, this is actually another interesting way that people explore ideas while hedging their bets. Is like, so one, how do you explore a new space? Well, build a game. Two, how do you explore a space once you've found some kind of product market fit, but you're not exactly sure what the company looks like? You consult, and you do consulting until you understand the idea space a little bit better. Once you understand the idea space and the enterprise customer process a little bit better, you can start to encounter, okay, what are the canonical use cases? How do we build an abstract platform for it? And then you start to get to the real engineering problems that are going to give you the most leverage once you solve them. So what were those hard engineering problems that you eventually decided to focus on?
Yeah, so it was really about listening to the customer and just understanding their initial problems. So I guess the first big project we had was many steps. And so it was about 150 steps with a really, really complicated piece of hardware, which meant, it was thousands or I think distinct parts. And so we built our software on top of Unity, and which actually, this was 2012, I guess. And back then, it was one of the hardest decisions I had to make, which was choosing a three-dimensional rendering platform. There was a whole bunch out there. There was Unity, obviously, Unreal, a few of the kind of lesser known game platforms. There was like open source software and stuff like that. And finally, we settled on Unity, mostly because when we first, actually, let me back up. When we first built that proof of concept for that trade show, the customer wanted basically the impossible. They wanted augmented reality glasses. And they wanted to, have a reliable, good-looking demo to show at this trade show. And so really the first step was they gave us a whole bunch of money and they said, hey, go buy a bunch of augmented reality glasses and like everything on the market. And if nothing is suitable, then buy some. So we did buy every pair out there. There weren't many. And we ended up building some. So, and that was incredibly challenging. That was, the first and last piece of hardware I ever built. But essentially what we ended up doing was we partnered with Epson, who had just launched a pair of glasses. They didn't have a camera on them, so they weren't really augmented reality enabled. But we ended up hot gluing a webcam on top of these glasses, running the webcam through USB to a laptop, running the computer vision calculations and the rendering on the laptop, outputting it to VGA, converting the VGA to a component, and then hacking the operating system on the glasses to accept external component input, and then displaying that view in the glasses. So this is one of the first pair of AR glasses. Total Frankenstein solution, but it worked as a proof of concept and clearly, kickstarted the company. But there was a reason we chose Unity as a platform back then was because it had a great plugin architecture that allowed you to plug in various 3 AR toolkits. So by this time we had kind of moved on from my homegrown computer vision solution. I realized at that point that there were companies that were actually working on real AR toolkits. They were doing it much better than I could. I could spend $2 million in R&D trying to build an AR tracking solution that wouldn't be nearly as good as some of the commercial guys out there that were really focusing on it, and who actually had legitimate academic backgrounds in computer vision, not just my hacky problem solving. And so, yeah.
This was even 6 years ago, people were building AR platforms.
Oh, yeah. I mean, there weren't a lot. At the time, if I remember correctly, there were kind of 3. There was Vuforia, who was owned by Qualcomm, who was actually an acquisition. There was Mataio, who got acquired by Apple and is essentially the basis for ARKit. And then there was another company out of LA. I can't remember now. Anyways. So
Mataio? So Apple kind of bought them and then developed it further. What did Mataio do? Or when was that acquisition?
So yeah, Mataio had been around for a long time. I believe they started in like 2006 or something like that. Although I could be totally wrong. And they were based out of Munich, and really initially were focused on the automotive industry. So they thought the killer use case for augmented reality was basically allowing customers to customize the look and feel of their cars. So if you could recognize the shape of a car and then change the paint and the grille and customize it, that would be really a compelling use case. And so they focused on a lot of those things. They focused on a lot. They did a lot of different things. They were kind of the same as us. They did a lot of consulting, but they also had this toolkit they released. They also had a very early version of the work instruction platform that we have that allowed you to kind of create a procedural animation type thing. But yeah, Apple acquired them in 2014, maybe 2015, I think. And it was because they had the best computer vision out there, the best augmented reality algorithms. They were also working on some interesting things with bringing the algorithms into silicon. So, the way you typically speed up calculations is, first you write it in a high-level language like C#. Then you can optimize it further by bringing in a C. Then you can optimize it further by doing a lot of assembly for your, really the parts of the code that need to be really fast. And then if you can't get that fast with assembly, then you build them into silicon, where you actually have specific hardware that can speed it up. So that's, how you get really good speed out of graphics card, because it's specialized hardware for doing those specific calculations. So I think Apple's strategy all along was to take these calculations and bring it into the hardware to really speed it up. And that's how ARKit is so great today.
Wow. Okay. It's incredible. This is what I hear about the Apple acquisitions. Like, Apple acquires a company, then you don't hear anything about the company for the next 11 years, and then Apple brings forth a fully developed augmented reality platform based on the technology they acquired 11 years ago, or 10 years ago, or 8 years ago, whenever it was.
Definitely.
Or you said they were acquired in 2015, I think.
Something like that. I'd have to do the research. It was 2014 or 2015.
All right, so maybe only 2 to 3 years to bring it out of silence, to bring it to market. But that's so cool that they put it into the chip. I mean, this is what you see with the machine learning stuff more recently, where everybody's trying to press the machine learning calculations into a special kind of chip, because why wouldn't you? It's, you got matrix calculations that happen all the time in a machine learning model. Why not make these more efficient by throwing them in the chip? But AR. So this AR. So help the listeners understand, I guess, a little bit what ScopeAR does, because you were building stuff long before ARKit made it to market. Okay, I think here's the question. ARKit came out recently. You were building your own software up until then. Actually, ARKit and AR Core came out recently. These are, Apple's augmented reality platform and Android, Google's augmented reality platform, respectively. Have you had to refactor the software that you built over time in order to run it on ARKit or AR Core? Because obviously you would like to take advantage of the on-device on-chip speed up that ARKit has, for example.
Yeah, so just to kind of clarify what we do, if I look at the augmented reality market, I kind of see three distinct areas, and they're kind of blurring into two. But there's the computer vision calculations that essentially take the measurements from the camera and other sensors like the IMU and combine them to get a pose. So a pose is essentially your orientation in 3D space and your position in 3D space. And by getting that pose, then you can augment your reality by placing a 3D object in the camera relative to some surface or something. And so in order to do that, you need really fast calculations to keep your pose updated so that you can change the position of those 3D models relative to the camera image, or in a pair of glasses relative to your vision, right? So that's the role of computer vision in augmented reality. The second kind of piece of it is the hardware. So whether it's phones or tablets or smart glasses, they need to be good enough hardware to be able to do those calculations fast enough. But also, the displays need to be responsive enough to update the image relative to where you're looking, so that you have a good experience. If you don't have if you don't have a fast enough processor or a refresh, then you get a concept that we call swimming, which is you move your device, but the camera doesn't update as quickly, or the position of the image doesn't update as quickly, and so it lags. And that means that the connection between your superimposition of this object over reality loses its connection to reality, and so you get kind of an uncanny valley type of effect where it just doesn't become real anymore. So where we really focus is the third piece, which is content creation. So as soon as you have really good hardware and really good computer vision, and you can create rudimentary experiences by placing things in your reality, now you need to make that useful. And so much like back in the early days of computers, we might have image programs to create basic images. Well, then somebody was bright and wanted to string a whole bunch of those images together in a video or in a PowerPoint presentation to illustrate something. And so you needed additional software to make that easy to use. So what we do at ScopeAR really is focus on that content piece. So our WorkLink product is kind of like PowerPoint for augmented reality. It makes it easy to bring in 3D models from your manufacturing processes and then build out a workflow to illustrate a procedure. And it's kind of like a Visio flowchart type thing. And for each step in the flowchart, you can associate text, video, audio, and video, and text-to-speech, just like you would in a normal procedure. But then you can also associate these 3D models and superimpose them on top of real equipment to show how to do things. And then the second piece we do is the remote assistance piece. And so this is content creation created in real time between an expert and a technician to collaborate and really solve a problem. So getting back to the original question, going back to the history of the company, so when we first started it, there were a whole bunch of different computer vision toolkits that were available, or I guess not a whole bunch, but 2 or 3. And more have definitely popped up recently. But we realized that the market was going to shift really quickly. These toolkits were coming out frequently. Hardware was being updated frequently. Now we're seeing a kind of a new device or a new set of computer vision technologies coming out every few months. So we realized that it was really necessary to be agnostic so that we could really quickly take advantage of the latest and greatest technologies. So we really built a layer that abstracted all of the hardware and computer vision capabilities into the platform. So what that meant was that when ARKit came out, it took us 2 or 3 days to actually adopt the ARKit platform, because it had all the same components and APIs that all the rest of the platforms did. You need essentially to get your camera image, you need to get the pose, there's a few other things you need to get, but it's a pretty simple abstraction. And so we're essentially able to plug and play. We'll do the same thing with AR Core. We did the same thing with HoloLens. If there's another toolkit that comes along, then we'll be able to adapt it pretty quickly as well. But, it's really just good software engineering, thinking ahead to be able to abstract it so you can easily plug and play.
When your application is failing on a user's device, how do you find out about that failure? Raygun lets you see every problem in your software and how to fix it. Raygun brings together crash reporting, real user monitoring, user tracking, and deployment tracking. See every error and crash affecting your users right now. Monitor your deployments to make sure that a release is not impacting users in new, unexpected ways. And track your users through your application to identify the bad experiences that they are having. Go to softwareengineeringdaily.com/Raygun and get a free 14-day trial to try out Raygun and find the errors that are occurring in your applications today. Raygun is used by Microsoft, Slack, and Unity to monitor their customer-facing software. Go to softwareengineeringdaily.com/Raygun and try it out for yourself. Got it. So I've seen a little bit of this as I've toyed around with ARKit, that if you want to build, let's say, if you want to build the Instagram for augmented reality, where you instead of putting a photo filter on a photo or putting a filter over a video, you want to have augmented reality assets come into that video, and then you can imagine the bright future where we're all wearing augmented reality glasses or contact lenses, and we walk past a restaurant, and a little pop-up comes up over our glasses that says, "Hey, 50% off a meal at McDonald's today if you come in." That's a pretty appealing advertising platform, but it's actually really hard to do for a number of reasons. One of which is there's not like an off-the-shelf way to build augmented reality assets. You've got to build these ad hoc 3D models. You've got to figure out how to get the 3D model into your app. You've got to figure out how to serve it to users. And then that's not even talking about how we're going to integrate sound and whatever else with those 3D models. You're talking about building a workflow manager for doing all of that stuff. It sounds pretty useful and sounds pretty flexible. And it sounds like you also have been interested in the whole augmented reality as an advertising tool yourself for a while. So I'm sure you've had these kinds of thoughts go through your head.
Yeah, absolutely. There's definitely a lot of moving pieces to it, some of which exist now and some of which don't. Like, for example, if you were going to do this augmented reality advertising platform where you're looking at a McDonald's and wanted to show an ad, there's a lot of pieces that go into that. So, the first piece, and this is where we're at, and it's pretty basic, is that you need to know, let's say if you've got a pair of AR glasses, you need to understand where those glasses are looking, where you are in space, both at a sub-millimeter level, but also a sub-millimeter level relative to the ground and to the store. But also, you need your GPS coordinates to recognize which McDonald's you're looking at and how far away it is. We can do that now, but the next thing is it would have to recognize at a pretty accurate level, not necessarily millimeter, but where that McDonald's is in real space, so that you could overlay that ad on the McDonald's. And then place that content in there and stuff like that. So we're a little bit far away from that. Computer vision isn't great at recognizing objects yet. It's starting to come, especially with the new machine learning features coming, baked into Apple's products and a few others, but also cloud-based machine learning platforms. You can do some kind of object recognition rudimentarily, but then moving that into an augmented reality context and really understanding what it is and overlaying on top of that, that's really challenging and not really feasible right now. One of the most common features we get asked is, if I'm looking at a piece of machinery, can it recognize that I've removed a nut or removed a bolt or put a wire in the right place? And, the answer is no. We're barely at the point where we can actually track you properly and know where your phone is in real space at an accurate enough level to show animations on top of that. But recognizing really small changes in a scene is really challenging. That's going to require a lot of machine learning to understand that is a nut, in fact, and that it has been moved from previous frames. And then to know, it's just a pure content problem that, that nut has been moved off of a bolt. So to recognize that and then to program it to recognize that, that's another challenge entirely. So there's a whole space of problems that are yet to be solved and areas of businesses that are going to be solved at some point.
In the area of self-driving cars, you hear the debate between people who are saying we need LiDAR, which is the lasers, I think, like lasers that help you understand where you are in space, and maybe they help with mapping. I need to do some shows on cars, but that versus computer vision. So so there's different ways of doing this simultaneous localization and mapping where you can just do computer vision, where you just have cameras around your car and you're bringing in the world and understanding from the computer vision the depth and where you are in space and where other objects are. You can also do lasers. You can also do, I think, radar or like bouncing sound around places to understand what's going on. It sounds like there's like similar debates in the like AR world because, for example, Apple, it has a new phone coming out, I think, that has lasers in it that are related to ARKit. Can you help me understand this conversation?
Yeah, absolutely. So it's all about the amount of information that you can perceive about the world and, having senses to understand what's around you. So similar to us humans, we have many senses. We have touch and hearing and eyesight to be able to understand where we are. And then that's all tied into a centralized system in our ears where the only reason we can stay standing up is because there's a tight integration between our ear and our mandibular vestibular system with our eyesight. So that's why we get seasick. And when you start to play with those senses in VR, for example, a lot of people get seasick because what they're seeing doesn't line up with what they're feeling and how they're moving. So similarly, in the computer vision, the autonomous driving world, you need to merge a whole bunch of sensors and derive information out of all that raw data. And there's a whole debate around processing power and how you get that in real time, because of course that's necessary to make decisions for autonomous driving, and then it's necessary in an augmented reality context to be able to figure out where you are in space, as I mentioned, and manipulate your pose to update your 3D models. So one of the reasons why ARKit was so amazing is because it was able to do really good augmented reality experiences with only an RGB camera. So an RGB camera is just a plain old camera, the same thing you'd find in an SLR camera or a webcam that we've had that technology for decades. So it gets a red, green, and blue set of pixels. ARKit essentially combines that camera, the information coming out of it, with the IMU, so your accelerometer and your gyroscope, to get that pose estimation at a very fast rate and very accurate. So I've been in the augmented reality space for a long time, and all previous toolkits that are out there that try to do this without fiducial markers, they could do it, but they had very high CPU usage, which made it really heavy on battery consumption and not viable for a lot of applications. But B, if you moved your phone too fast, or if you moved it out of the area of initialization, so for even the best ones on the best hardware, you'd get like 45 degrees of freedom. And by that I mean if you were looking at an object, a coffee cup, for example, and if you rotated it 45 degrees around that coffee cup, it would usually lose or at least drift the estimate. And that's because of the accumulation of errors. Because you're trying to merge the sensor information from your IMU with your camera, sometimes they don't match up, and so calculation errors start to accumulate over a period of time, especially if you're moving your phone quickly, then you completely lose it. What Apple's been able to achieve is a really great experience where it essentially never loses the tracking, and that's really remarkable. previously, if you wanted that level of detail, you needed to do something like Google Tango, which incorporated a depth camera. So this was another device that it was essentially a laser. So it fired off an infrared laser in front of you and then reflected that laser back into a sensor on the phone, kind of like a flashlight. And it measured the time difference between each pixels. So what that meant was you actually got RGBD, so D stands for depth. So you got a really accurate depth measurement. And using that information, you can plug that into the tracking algorithm and get that level of tracking accuracy. And that also gives you some really other interesting other things. With RGB, essentially, you get it's called a point cloud. So if you can track various points in the camera image, if you get a slight difference between, if you move your phone even a few millimeters, points that are further away are going to move less in your camera image than if they're closer to you. And so by measuring the difference between those points, you can get a measurement of the three-dimensional distance. And by doing that, then you get a point cloud. But it's a very sparse point cloud. You might get, about 1,000 points in any given camera image at best, and on average, under 100. But with a depth camera, now you have a very rich point cloud. In fact, every pixel in your camera is now a point in 3D space. So you can do really cool things like building really complicated and detailed meshes. You can go around and scan a room. You can scan a chair and objects, and you can recognize objects. So that's kind of the differential between the two of them.
Okay, let's go a little deeper there. So any frame that I am seeing in the world is basically a bitmap, right? Like it's got an every little pixel on my screen is representing an RGB, but in the world where we have a laser in our camera, there is also a depth associated with each of those pixels. Am I understanding the mapping correctly?
Correct, yep.
Okay. And that gives us a more accurate view of the world, especially from the point of view of or I guess it gives our computers a more accurate view of the world. Now, so in order to generate that the depth that is associated with each pixel on a frame, does the laser that's getting reflected back, how hard is it to map the feedback of the laser accurately with the image that's coming in through the other camera? Or are there multiple cameras, or is everything coming in through the same camera all at once? Or I don't know. Do you know much about that, or does that get too much into physics and stuff?
Yeah, no, absolutely. So there are two cameras. One's the plain RGB camera, and then the second one is the depth camera. And so the way the depth camera works is it shines this laser on a particular pixel and then waits for the reflection of that laser beam, and it's got a unique timestamp or a signal on it. So it recognizes that reflection is that pixel. And
oh my God,
based on the timing of how long it's taken to reflect off of that surface, you know how far away it is.
Oh my God!
We're talking extremely accurate measurement, right? And especially if you're doing that, many times a second for every pixel in your frame, you were talking I'm not sure what the scale is, but I'm guessing either nanoseconds or femtoseconds. And but you're able to get a fairly accurate depth map. We've done a whole bunch of testing on this, and you can get sometimes half a centimeter in accuracy, and the only reason it's not that accurate is because depth cameras are really power intensive. Lasers aren't cheap, so you're shining this laser out, and if you shine that laser out many times a second, the CPU frequency needs to go up, and yada yada yada, right? But yeah, that's essentially how a depth camera works. Is it's capturing that time of flight.
So it's no surprise to me that Apple is pouring money into this, pouring resources, pouring strategic efforts into ARKit, because this is an area where their manufacturing expertise can keep the costs reasonable while still getting super futuristic hardware features. And you can imagine this as being a durable competitive advantage against Google as Google tries to move up market in the smartphone world. Now, is AR Core doing something similar to ARKit?
Yes, yeah, it's almost a direct copy, and there's reasons for this, and I think it plays into more of the strategy that we're seeing out of Google. So just to get down in the weeds a little bit more, what you need for the amazing experience that ARKit has provided is tight integration between the hardware units. So your IMU is doing measurements many times a second, and then your camera is doing measurements many times a second. And you need to fuse those two sensors many times a second to get your calculations. And as I mentioned, the reason why previous efforts at this had failed was because of accumulation of error. So what's really required is a centralized time chip where when you get a measurement from the IMU, you get the timestamp on it incredibly accurate, and you can line that up with the timestamp on the camera incredibly accurately. And by doing that, you can minimize a lot of the error, because if you can imagine if you have kind of offsets between the measurements, your IMU, the measurement from your IMU was done a split second after the measurement from the camera, you can't account for the very small amount of movement, and so your calculation is going to be wrong, and that error will accumulate over time. So Apple's been able to do this because they control the entire hardware stack. They've had this integrated time chip from day one, essentially. With Google, because they've got such a fragmented ecosystem in hardware, and because Android manufacturers can only really differentiate themselves on a few key pieces now, one of which being the camera, they really don't have this tight integration where, you see your time chip might be on the SoC for one chip, which is distinct from your camera unit, and so then you can't really do the proper calculations, and your error accumulates. So with Tango, what they did was they mandated a certain bill of materials, which was, you needed this depth camera at this specification, this camera at this specification, and this chip at this specification. And so the manufacturers like Acer and Lenovo were able to manufacture these and deliver the experience that Google required. With AR Core, if you notice, AR Core is only going to be supported on a couple of phones, i.e. the Google Pixel and the Samsung S8. And my guess is that that's because they kind of got caught with their pants down when Apple did ARKit. And so they, really quickly went to Samsung and HTC, who manufactured the Pixel, and was like, okay, we need tight integration between these things in order to produce AR Core and keep up with Apple. And, very shortly after, they acquired HTC, which indicates to me that they really want to take control of their hardware top to bottom. So I think there's a few other reasons for it, but I think that was probably a large reason for it. They're a little bit behind in the VR game against Facebook with Oculus. Daydream, they've done a great job with Daydream, but I think they wanted to bring the hardware for the Vive kind of in-house and really be able to drive that. But then in the augmented reality game, if they were able to tightly integrate the manufacturing with HTC, with their Pixel line, that will just help them in the future. So I think they are trying to take more control. And it's really interesting because, historically, Apple tried to control the hardware back in the early Mac days, and that strategy failed miserably. The strategy that Microsoft took, which was, and Intel, which was kind of, the piecemeal, you can build computers yourself and blah, 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 that really worked out in that space. But what we've seen in the smartphone space is that modular componentization really hasn't worked out. Google's Project Ada or whatever it was, they tried to build a modular smartphone, failed miserably, and now they're following Apple's lead and building really tight hardware integration top to bottom.
You gotta love the Apple haters who have been talking about how Apple doesn't innovate and Apple holds on too much cash and they just accumulate cash. And it's like, well, sometimes you got to hold a lot of cash because you're going to have to do some crazy investments in hardware advancements, and like holding on to the platform is just like, Apple's in a business where they had to stockpile cash, and I think now we're going to start to see why that is.
I completely agree. I think their spending on this space and R&D is going to be tremendous, and we're going to see some really cool things come out of what they're doing.
Yeah, okay. I know our time is getting somewhat short, and there's so much more I wanted to ask you about, but let's quickly go over HoloLens. In this world where Apple is suddenly leading the way with its hardware integration, and Google is struggling to catch up by acquiring HTC and trying to integrate its hardware all of a sudden, where does Microsoft sit with the HoloLens? Yeah,
interestingly, Microsoft kind of led the way in this. The HoloLens came out way before ARKit and AR Core, although, if you go back, Apple was obviously doing acquisitions in the AR space many years ago. I really like the HoloLens. I think it's a fantastic device. They achieved essentially what ARKit did with really robust tracking in a head-worn device. And there's a lot of problems with it. The field of view is small. It's a bit shocking when people first put it on. The whole user interface and how you interact with the operating system is not great. Gesture interaction is not great. They've nailed voice control through Cortana, so that's great. But overall, for a first try at a true augmented reality device, I would argue that Google Glass was not a true augmented reality device. So this is the first real viable AR device with really robust tracking, which is really what you need for a good augmented reality experience. They've just nailed it. So I'm really excited to see what comes in the next version. Now that they put it in market and they've learned what the core competencies of the device are and the killer use cases as well as the deficiencies. So I think the next version is going to be fantastic.
So can you contrast it? Like, how does Microsoft fare as a hardware company these days?
Well, it's interesting. They gave up on all their phones, but I think they're really making a big bet in the AR space with HoloLens, and then the mixed reality platform that they're building, where they've got a whole bunch of partners for virtual reality. So I think they're doing everything right. I think they're keeping up with, and actually, Facebook didn't do so well with Oculus. Oculus' sales haven't been great. I think they really overpaid for the platform. HTC kind of came out of nowhere and really dominated that for a long time. But Microsoft, I think, is doing a really great job at really identifying that niche, and I'm really impressed, to be honest with you.
Have you seen Magic Leap?
No, I've tried a bunch of times, but haven't seen it yet.
Have you heard anything about it?
Not that I can say.
Okay. All right, we'll have to get coffee sometime.
Definitely.
Maybe you'll tell me. Off the air. Okay. Well, I guess we're nearing the end of our time. This was great, though. We definitely have to have you on again in the future, hopefully. Well, okay. Why didn't Google Glass work?
I think Google Glass was released prematurely, and they put it out there. I think it got out of control, honestly. I think they put it out there to see the public's reaction, and somebody decided that a mass release and, it was going to be socially acceptable, and this was great. And the public backlash was just, we all know what happened. But I really don't think they thought through the use cases. It was really not ready for prime time. I got mine, and I was really excited about it for about the first week, and then I put it away, and then it hasn't seen the light of day since that first week, which is crazy for a $1,500 device. That was a giant waste of money. And I think most people felt that way. I was at Google I/O the year they launched it, and virtually everybody had theirs on as a badge of honor. And just a year later, I saw like one or two guys with it on. So that fad really faded pretty quickly. But it was because you couldn't do anything with it. You could maybe take a screenshot, or you could, send an email really quickly or a text message. But it was nothing you couldn't do with your smartphone, and almost arguably easier. I thought the killer use case would be when I go cycling. I would be able to take screenshots and keep up with my text messages, right? But it didn't work. While I'm cycling, the voice control didn't work because it was too loud. I couldn't take my hands off my handlebars to play with the rudimentary gestures, and so that killer use case didn't work. And I really couldn't find a utility for it. I'm not sure clearly people couldn't. But, there, like anything, there are killer use cases for it, and I think they've found a nice niche in the enterprise again, and that's delivering really rudimentary text instructions in your field of view to workers. And that solves the problem of workers not having to carry around papers or tablets that can get broken or dirty, and they're tough to handle with work gloves on. Now you can just talk to your device, and it shows you rudimentary things. And so again, coming back to the enterprise, that's really where the use cases are first being adopted with this admittedly clunky technology. But if it saves time and money, businesses will adopt it.
All right, Scott. Well, it's been great having you on the show. Next time you have a product launch or you give a conference talk that you want to get some broader appeal to, let me know. We'll have you back on the show. It was great talking to you.
That'd be great. Very nice talking to you too, Jeff.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, Find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!